Hey there, it's Bruce Wayne here. Well, close enough anyway. Oh, geez, this mask needs an exit strategy. Oh, there we go. Hello, everyone, and welcome to my live stream. I'm Bruce Wayne from Brankus Creations, and today I thought I might do something a little bit different to usual. I am obviously usually just doing recapping, just grabbing boards like this and taking caps off and putting new caps on. And to be honest, if I start boring people, that is exactly what I'll do. But what I thought I would do today is actually spend a little bit of time just talking about some soldering techniques that I have learned, mainly because when I get quite a lot of comments on some of my YouTube videos with people saying, you know, sort of, oh, I can't get the solder to behave the way I want it to, or how do you get to do that, and all this sort of stuff. And so I thought I could take the opportunity to just sort of talk over some of the equipment that I use and some of the techniques that I use to make solder do what I want it to do. Hello to everyone who has jumped onto the stream. If you're a first timer, please jump on and say hello. I am going to just work my way through. I see House of Moth is there, so hello Jay. I see Steve is here. Hello Steve. Googie Clone, hello. Dana is there. Aaron is here. Trina is here, and I think that's all. So anyhow, now that I assume everyone's getting over the shock of the intro there with my Batman mask, but look, Bruce Wayne, come on. So hi Leo, welcome to the stream. So anyhow, I'm going to just sort of go over a few little soldering techniques, and I'll demonstrate a few under the microscope and all that sort of stuff. I've got a new little side angle camera here. Well, it's not a new one; it's an old one, but it's I've got now 1080p coming from the side view here. And I'm actually looking here at this is one of my one of my earlier soldering irons. I won't say my first, because one of my first soldering irons was actually one of those just all-in-one that plugs straight into the mains power. This was probably one of my first soldering stations. I did actually have another one that was virtually the same as this, and it broke, and so then I bought the exact same model again. Yeah, lack of choice, I guess. This is bought from Dick Smith, which is an old electronics retailer that used to exist in this country, but they sort of don't really exist anymore. Yes, no, well, yeah. Well, I mean, what's Batman going to do these days with the whole COVID situation? Just don't make a soup out of him. I think that's the main thing. So anyhow, this was one of my first soldering stations, and the reason why I tend to recommend against these sorts of soldering stations over some others, there's nothing really wrong with these. Good thing about it is they have a temperature control, which is really important when you're doing soldering. This one here has a sort of an analog temperature readout, so this one's obviously got sort of feedback. It's got a sort of thermostat thingy in the handle that tells you what the temperature is. But with a lot of these, hello Nate, welcome to the stream. With a lot of these sorts of soldering stations, they all work in the same sort of way, and that you have the handle here. Well, you've got your base station with your temperature control and your power controls. This one has a light to tell you when it's on, and then a light to tell you when it's up to temperature that you've set it for. And then you have the heating element in this handle. And then what you have is you unscrew this, take that out, and then we've got a little tip there. And basically what happens is this is the part that this is the heating element that gets hot. These can be replaced. So you can undo these and buy replacement ones, or you used to be able to, not for this one, but for a lot of them you can buy replacement heating elements. It's always not a bad idea to have a spare one around. And then obviously the tip goes in, and that goes in to hold the tip in place. Now, this iron has seen a lot of use, yeah, and it's also been stored rather poorly. It just needs to be thrown away. I mean, I cannot see myself ever using it again. Now, what I don't particularly like about these irons is that, first of all, the heating element is in the handle, and that heat then gets transferred to the tip, and then you end up losing quite a lot of heat during that process. So they're not that efficient. You don't get as much heat to the tip as some other forms of soldering iron. The other is that if you decide partway through soldering that you want to use a smaller or a larger tip, you have to either wait for this to cool down, which does take a long time, or you have to try and unscrew this with pliers and pull this out without damaging it, because often these heating elements can get a bit fragile when they're really hot. So these what a lot of people, you know, are probably used to. I mean, there was once upon a time this was it. I mean, when you wanted to buy a soldering station, this is the sort of configuration they were, and indeed a lot of the ones that are being made these days still are. But I much prefer the what's sort of generally referred to as the T12. So this is my soldering station here, which I I can get it out, but I'll unplug it in the process. So this is Hakko FX951 soldering station. I have lots and lots of complaints about this, but one of the things that I really do like about it is the way the tip works. I mean, first of all, it's very small. I mean, as you can see, compared to the other one, this one is more like holding a pencil, whereas the other one's a lot bigger and fatter. This one here which is of course extremely grubby. I really should clean that, shouldn't I? What is really funny about these is like in Australia in particular, you pay a lot for these. These aren't really a budget soldering station. They're quite expensive. A lot of this stuff, I mean, things like this handle here, I mean, they're so flimsy. I mean, these can just come apart really, really easily. It's a shame, but you know, replacing these handles is not that expensive. You can do that, and you can even buy copies. This handle is a genuine Hakko, but you can buy you know, sort of Hakko knockoffs that will plug into these base stations. So the main reason why I like these is, say, because they're lighter. But the really important thing is the fact that the tip itself is the heater. So that's a T12 tip, and that whole thing is the heating element. And so that means they're far more efficient when it comes to heating. So yeah, so you know, that's what I really like about these particular soldering stations. And of course, this is hot. I mean, if I touch the end of that, I'll burn myself. But I can hold this quite happily down here at the base of the tip, and then I can swap tips over mid soldering. So that's a really, really important thing. So I would generally recommend that if you're going to get a soldering iron, get one that uses T12 tips, and it doesn't have to be a Hakko. There is a link in the description for where there is a budget T12 soldering station, and you can basically buy genuine Hakko tips and put into that T12 station. So you know, you get the best of both worlds. You get the nice sort of cheap base station, and you can use the quality tips. So that's kind of the first thing is the station itself. Now, what I really don't like about this station, it's actually, I should mention another thing I do like about it. It's rigged up so that when you put the soldering iron into the little holder like this, there's a little lead coming out of it, and when it feels that the iron is actually in the station, it sends it back to the into the what do you call this thing, stand. It sends a little message back to the station saying the soldering iron's not being used, and then after a moment it powers down and it just switches off. And so that's really, really handy if you're like me and you're a bit forgetful and you sometimes forget you are halfway through soldering something. You head out of here, and then you find that you've left your iron on, and of course this just switches itself off, so which is really, really good from power and from a safety perspective. So so that's one of the things I say that I like about it. The things that I don't like about it, I really don't like the interface of this thing here. Oopsie, what have I done? I've just lost my screen here, so I can't see anything. So I'm hoping that I'm still streaming, but I'm assuming I am because all the cameras appear to be on. But I have completely and totally lost my ability to see anything. So I apologise. Bear with me just a minute while I try and figure out, did I just press the power button? Where is the power button? That's a good question. This is going well, isn't it? Excuse me just a minute while I just hop under the desk and see if I can find out where the cable of this screen is going. Okay, and it was kind of an odd one because I just pulled the cable and then this suddenly went blank. Oh, it's come back on again. Oh, there we go. Okay, sorry about that, folks. Okay. So, I won't be doing that again in a hurry. I'm not quite sure why it switched off, but once I unplugged it and plugged it in again, it worked again, so. Okay, so, as I say, one of the things that I really don't like about this is the interface. If you're wanting to change the temperature on this thing, you have to go, oh, we've got him on. Okay, so I've got him on the temperature there. If I want to change the temperature, you've got to, what is it, you put the key in or something, and then it starts flashing, and then you go up and down. So let's just say we want to leave that there. You press star to move to the next number. I'll make it say 440 star. Okay, that's locked in, and then that's set at 440. And if you don't have the key in, you can't make an adjustment. Now, I don't know. Someone can perhaps tell me why it is necessary to have a key to change the temperature of your soldering station. Are you really in a situation where you're going to give someone a soldering station and say, you just solder, don't you dare change the temperature? I mean, it's just the most ridiculous thing in the world. And then, of course, this whole thing of selecting the digit and then changing it up and down. There's no real apparent, let's just say I want to change this to 460. I'll just go, sorry about the focus, guys. Let's just say I'll put my key in. I'll go 400, I'll go to that one and I'll go up. 460. Actually, let's make it 470. Star. No. Won't let me do anything. The reason is that that's temperature too high for this interface. No error, nothing. You just hear pressing buttons. It won't actually accept it until I choose a number within its range. I think 450 is the highest it'll go. So anyhow, just monumentally stupid stuff. Someone in it was Nate mentioned having the FX888, which has the knob. I mean, so much more logical. I like a digital readout to show me what the temperature is, but just having a knob to go up and down temperature is just so much more logical. This is just stupidity. But anyhow, that's enough of my hatred of the interface of the FX951. Apart from that, and apart from the fact that it is coloured to look like a kid's toy, it's a good soldering station. I do very much like them. So anyhow, that's that with the soldering station. Now, the other thing I want to talk about are tips and getting heat where you want to get heat. Oh, Grudy, hey, well, welcome to the stream. Okay, so what just looks like something easily lost, but probably costs way more than the plastic is worth. Oh, you talk about the key, yeah. Yeah, I mean, I'm tempted just to open this thing up and make it so that the key can just be a switch at the front or something like that, because it's just so stupid. Anyhow, I digress. Okay, so one of the really important things with... oh, Dana, are you here? I've already said hello to you, haven't I? Yes, I have. I'm sure I have, yes. Yes, I'm sure I have. If I haven't, hello. So I have a whole series of soldering iron tips here. I'm going to just bring them all out here with my specially homemade designed stand holder for them, made out of a piece of wood. I'm just going to go in and just very quickly alter my focus here so that it is not on autofocus. Let me just, there we go, because I'm sick of it auto-focusing all over the place where I don't want it to. Yes, I have said hello. Yeah, good. Yeah, just you know, it's what is it, 11 o'clock on Sunday here. I can't be expected to be in full form at this time. So I basically bought this. I bought a knockoff soldering station, a Hacko. It looks like a Hacko, but it's not a Hacko, and it's not well made as well, but it still works okay. And with that, I got a whole series of tips, and that was fantastic because it gave me an opportunity to try lots of different ones and figure out which ones I like. Now, most soldering irons come with a conical tip, so that is one that goes to just a fine point. And you might just sort of think to yourself, well, a really fine point for doing fine work, that's the way to go. But one of the problems is that with soldering, the three things that you need in order to get good joins are having the contacts clean. Whatever you're trying to solder, make sure it is clean. Having heat where you need it, and having flux. And the thing is that if you can't get the heat where you need it, you're not going to be able to get, do good soldering. And so I could get this iron here and I could melt some solder onto it. But if I then put this tip onto something, I have a lot of trouble transferring the heat from the tip to what I'm soldering. That's because there's just not much surface area. The surface area is a really important thing. This is why I much prefer to work with, this is the sort of tip that I use here. I can go up here and do a little bit of focusing so I can maybe go. How close can I get? Yeah, look at that. How close is that? Yeah. Now this is a bevel. It's sort of a little beveled edge. Oh, God, I'm having trouble doing it with my left hand. Let's try it with my right hand. Okay, so there's a bevel tip there. This is an old one, but there's a bevel tip there. Now that flat surface there enables me to apply heat to a nice surface area. So this transfers heat really, really well. Helps me out with soldering. But then at the same time, because it's the bevel, we have a point at the top. So I can use that to get into little fine nooks and crannies and stuff like that. Some people opt for these sorts of tips, which are sort of like a wedge in there like that. There is a word for it, but I can't remember what it is. And these have the advantage of this large flat surface area on the side, which again you can use to get heat where you need to get it. But then you also have this fine point on the end. So your tip actually has double purpose. You can get the heat where you want it, but then you've also got a very fine point if you need to get into into tight little places. And then the last sort, and this is one where I've seen quite a few people use these ones here. Now this is basically, apart from the fact it's got some hair on it, this is essentially like a conical tip. It's got a point. Whoa, there we go. But it's bent. And the reason why people like to use these bent ones is because you can actually get that bent part and lay it flat onto a surface and again transfer a lot of heat to where you want it. It's all about getting the heat where you need it. And then of course the other thing is I also have, I'm just going to change this focus back. I also have some quite large tips. I've got one sort of like this, which is a bevel, but it's got a great big massive surface area. And that's one that I would use if I'm trying to solder onto, a great big piece of metal and I need a huge amount of heat to where I'm going. So it's, it's not just a matter of saying, oh, this is the soldering iron tip that I use. I will use different tips for different tasks. And it all depends on, sort of where the heat needs to be. A lot of the time, if I'm trying to wick old solder away, I'll use one of these larger tips that I can get a lot of heat there to help suck up the solder. Okay, so I guess what I might do now is actually put some of this into practice, because goodness me, it's been enough of me talking, hasn't it? So I've got a logic board here that is a Macintosh 2VX. And this one suffered from some rather horrendous battery leakage. And there's sort of some really bad corrosion and that. And so what I'm going to do with this, I'm going to remove a couple of components, clean up the pads underneath them, and then put those components back again. And we might even do some really adventurous stuff in this as well. I might even look at taking the CPU off or something like that. So, so for the different types of ICs, I use slightly different methods each time. So I'll try a couple of different types of ICs. I'll lift them off, clean them up, put them back on again. So first thing I'm going to do is just look for something that might be like really grubby and worth removing. Just grab some tweezers here. Got a little piece of solder that looks like a horsey. Okay, so let's go here to that, and we will get some focus on the screen there. And oh, I need to get some focus here as well. Yeah, and there we go. All right. Okay, so we see a lot of exposed traces here, and that's really the problem with this board. I may or may not get it working in the future, but at this particular time, this one doesn't work. I have replaced lots and lots and lots and lots and lots of components on it, but there is still, it's still definitely not working. So, oh, look at all this lovely leftover solder. This is just one of the joys of batteries. I've got a nice big glob of solder on here. Let me just get rid of that. Okay, so let's just have a look around and we'll see if we can find something that looks particularly ugly. I mean, this looks particularly ugly. I wouldn't consider this to be a problem, but if we have a look just here, you can see all this kind of rusty stuff going on here. So I'm going to take this component off. I'm going to clean things up. I'm going to put it back again. Customer came to pick up a repair. Did I miss anything good after the T12 was mentioned? No, sorry, Jay. I've just been talking rubbish. So yeah, so I was just basically going over different solder tips, and I'm sort of talking about the importance of transferring heat. That it isn't just about having a really, really fine tip. It's about making sure that that tip can transfer heat onto what it is you're soldering. And then what I'm going to do now is I think I'm going to remove, clean up, and replace this chip here and this guy here. Now he is a was it PLCC chip? I think that's what they're called. These are ones that can be soldered directly onto the board, but they can also sit in little sockets. I do have some of those sockets around here, but actually, no, this is a VX. If it was a 2VI, there would be a socket on it. But yeah, so these, so as I say, these chips have the advantage that you can either put them into a little socket or you can solder them directly onto the board. So first thing I'm going to do is remove it, and I'm going to do that with my hot air station. This is my hot air station here. I can talk about that in a minute. I generally regard them as an essential item if you're going to be doing sort of electronics work. You can spend a lot of money on them, or you can get them for quite cheap. But this is not a, well, sorry, I shouldn't say that. Yes, this is a customer's board. However, it is it was one that was sent to me with someone saying, can this even be fixed? And I said, look, I can make no guarantees in the state that it's in, but I can certainly try. And when with all of these, I mean, to some extent, this has become a little bit of a pet project. I'll have a little bit of a play around with it every now and again, and then try it out and see if it works. I can get the power light to come on, but it doesn't chime. And if I get to the end of it and I can't fix it, I'll end up just giving it back to the customer and saying, look, this is too far gone. When you look at the state of some of these, oh, that's my big tweezers, don't want those. When you look at the state of some of these little vias here, you can see that they're pretty heavily sort of corroded. And then any one of these may have broken somewhere. And so, they aren't necessarily going where they're meant to be going. And, you could spend a lifetime trying to diagnose those, especially when with a board like this, I don't have a schematic. So I don't really have any way of knowing where a signal is supposed to go on this, other than sort of, having a working board and doing some sort of tests there. But I mean, that's something that you could lose weeks on that. So as much as possible, what I try and do with a board like this is search for the most obvious, the most visibly obvious problems. But with this one, there are quite literally so many that even that, I mean, I have already spent at least a day, I'd say, on this. I've replaced 1, 2, 3, 4, 5, 6, 7, 8, probably 10 or so chips I've IC sort of carriers I've taken off the board, cleaned the pads, put them back on again in the hope that that might sort it out. Because some of the pads were, the solder was completely gone. It had corroded through. I put it in the ultrasonic cleaner, cleaned it, and then when I then looked at it under the microscope, there were contacts that were just, the solder had just been completely rotted through. So I digress. Let's now look at removing this little IC here. I've got a little heat shield in place to try and shield some of the components from the heat coming off this hot air station. And I've just got to work my way around here, melt all of the solder so that I can get this guy off. You obviously would never be able to take a component like this off without a hot air station, because you can't get all of those pads hot at the same time. Time for the BFH. What's a BFH? Can someone tell me what a BFH is? Are you late? Yes, terribly late. Terribly, terribly late. No, I mean, really, you haven't missed anything. I haven't been doing anything of significance or importance or anything like that. I've just been chin wagging. Okay, so the next thing we need to do is obviously clean up these pads. We've got our component off, which I have just put over here. Let's have a little quick look at what it looks like underneath. Now with this one here, I can see that it pretty much was making contact on all those pins, because I can see that there's melted solder on all of them. But let's just clean this up and put it back anyway. So first step is we need to get some flux onto here, because that's going to help sort of recondition these pads. What we need to do is we need to make sure that every single one of these pads looks, like a nice, clean, shiny little, what do you call it, ellipse sort of thing, lozenge. Oh god, this thing gets so dirty. Excuse me while I just clean this up. It could indeed be the issue with the sound chip. So most of those old Macs have surface mount electrolytic caps around the sound chip. I'm just going to have a look at this one here and see if it does, but I know certainly ones behind me do. I'm not even sure where the sound chip is on this one. They're usually fairly distinctive. Let's just go to this one here because it's right here. This is a Color Classic board, and what we have is a sound chip, and then we have electrolytic capacitors surrounding it. And so many of those early Macs, they had electrolytic capacitors. I mean, I realize these are tantalum, they're being replaced, but they have sort of electrolytic capacitors around that sound chip. And what can end up happening, you can replace these caps, but what's happened is the electrolyte has leaked in underneath that sound chip, and it's made a mess of the traces, pins, bears, you name it, whatever. And I did have a situation once where I had a board that looked in really good condition, no sound after recapping, took off the sound chip and just found all these broken traces down this side here. It was running down there, and I just had to go in and repair all those traces. And once I did that, magic, sound came back again. That can definitely be the case. Now let's jump across back to the microscope and let's get some of these pads clean wherever they are. There they are. So flux. Talked about flux before. Going to talk about flux again. Flux is designed to stop or slow oxidation, depending on which part of the world you're from. In my part of the world, we say oxidization because we like to throw in a few extra syllables here and there. And that is, you know, it's basically the effect of oxygen reacting with the metal, and it creates a coating on the top of it, creates a sort of an oxidized layer. And this helps to stop that layer from forming. And that just means that the solder can flow without getting a crust on the outside. So flux is incredibly important. You know, it isn't just a matter of saying, oh, you know, it's an optional extra. If you are wanting to get good quality joints, and I can show you. If I get this soldering iron here, and I put it on to these pads, there's solder on them. So, okay, great, there's solder. And I just rub this soldering iron around a little bit. I mean, you can see that I'm really not achieving anything here at all. That solder is crusty, it's messy, I'm not cleaning those pads, it's not looking any better than it looked before. So I'm going to now apply some flux to this, and you'll see a very, very different thing happening when I do this. You see the way that virtually instantaneously we ended up in a situation where we cleaned off those pads, and you know, sort of they're now starting to look like they're accepting solder across the whole surface of the pad, whereas before they were only accepting solder on that little clean section. The little grubby section wouldn't take solder on. So whenever I'm cleaning up these pads, I always use some new solder. So I've got some new solder here, and flux and heat. And again, this is my bevel tip, so I'm putting the flat side of that bevel tip down, and I'm gently rubbing. Just doing it in a circular motion here, barely touching. I mean, I am touching, but barely touching. I do need more flux here. Once I start to see that flux, you know, sort of separate, you know, it's generally, you know, you end up with the flux on either side. It helps if I go, did I just bump that? Yeah. If you know, when you start to see the flux sort of moving to the side and then just leaving a section in the middle where there's no flux, it's time for more flux. Sorry, people are messaging me at the moment. Okay, so again, just circular motion here, cleaning those pads up, getting new solder on them, getting rid of all of the black crusty stuff. These ones, I need to turn the board around, I'm afraid, because otherwise I'm going to melt some plastic, and I really don't want to do that. There we go. Okay. Incidentally, if you're wondering what this chip is that I have removed, I'm not certain, but I'm pretty sure I didn't pay too much attention. But I think it's a it's for the serial port, I think, but I don't know. Okay, so, geez, I'm sorry about how shiny this this image is. It's a bit smeary, isn't it? I wonder if these lenses are dirty. Let's just see if I can clean them up. Don't think that made any difference at all. Try with a little bit of isopropyl alcohol. There we go. It's all nice and smeary. Okay. Are you testing those through these before putting it back? Well, it would be a sensible thing to do, and I may end up even doing that. But I'll wait and see. Once I get them all cleaned up, I want to have a closer look at how they all look. So I'm now going to get some solder Wick, and this is the braided copper that has some flux in it, and it basically draws solder to it. Really, really important thing to have in your toolkit if you're going to be doing any soldering. And I'm just going to place that down, and you got to be really gentle with this stuff. And the reason you have to be gentle is that if you don't have enough heat in your soldering iron, and you do, say, a little bit of this, and then that is now soldered onto the board. And if I give that a yank, I'm going to take a pad with it. So you need to make sure that if you're moving this wick around, you need to keep heat on it so that it can keep moving around. And I'm just using this wick to soak up the all of the solder, as well as doing kind of like a gentle scrape to clean up these pads. And what I want to end up with at the end are pads that look like they're fresh out of the factory. Now on an old board like this, I can tell you, it's not the case on a new board. If you're using like a new Mac or something like that, I say Mac because that's what I generally work on. I'm just going to get some isopropyl alcohol here, which thankfully I bought 5 litres before all of this fun and games happened, because trying to get hold of isopropyl alcohol now, I mean, the place I buy this from, it's a place just only a few kilometres away from where I live. Their warehouse, I just normally go in there and say, 5 litres of isopropyl alcohol, please. And then I went on there the other day and they had none. Every single bit of isopropyl alcohol sold out. And I was like, what? So, thankfully, I bought some before all the dramas happened. Okay, so I'm going to, I see a question there from Leo about the temperature of my soldering iron. I realise this is something that I really should have covered before, and I am going to cover that in a moment. So look at these now. I do apologise how kind of smeary it looks at the moment. I will endeavour to fix that before my next stream, but there's not much I can do about it now. But you can see now that these pads are all nice and shiny and clean. Now that is the perfect recipe for then putting something on it. Once you get them looking like this, it's going to take on solder beautifully, and that means that putting that component back on is going to be a lot easier. When you're trying to put components or wires or whatever onto something that's dirty, it's just a nightmare. The solder just does not want to go on there. The solder doesn't want to adhere, and then you just end up putting more solder on, and you end up with globs, and it just looks awful. So that is just my little rant there. The vias here, I mean, if I zoom right in, I don't really think there's anything wrong with these vias. I mean, although they look a little nasty, I would be very surprised if those vias didn't actually make it through to the other side. I'm pretty sure there'd be continuity there. And in terms of continuity, just say along here, I can see that there's no break there, so I'm confident about that. I don't really need to do any testing of that. As I say, I can, if I was being super diligent, I would, test through to the other side, but I'm not going to do that now because that would be even more boring than what you're watching now. So, okay, so now we've got to get this component back on, but before we do that, I just want to answer the question about the soldering iron. I use my soldering iron on the highest temperature it will go to, which is 450 degrees Celsius. I'm not sure what that is in Fahrenheit, but it is the highest. Now, that is, for a lot of people would consider that excessive, and I'm not necessarily saying that's the way you should solder, because heat can be very damaging to a board, in particular if the iron is on it for too long. These here, if we have a look at a pad like that, just here, that doesn't go anywhere. Now, as I say, if we were on a newer Mac, you could potentially have a little wire underneath that, taking it to somewhere else on the board. On a Mac of this vintage, I can look at that and see no trace coming from it, so I know that that pin on that component is not used. So that there is an unused pad, and I'm just going to use that to demonstrate how you can, actually I'll do this end one, it'll be easier because he's also not going anywhere. If you apply a little bit of heat, it's actually really easy to remove a pad like that. And you see how easy that was? Once I applied some heat and a bit of pressure, and that pad just came straight off. Let it go. There it is. So you have to be really, really careful with the high heat. So hello Dana, hello another Dana in the stream here. Thank you for joining. So yeah, so when it comes to the temperature, I use a very high temperature because I like to work that way, but it can be very dangerous. So you do need to be careful. So when I'm running at 450 degrees Celsius, I kind of regulate the heat by the amount of time I put the iron onto whatever it is I'm soldering. So I make sure that I only have it on there for a very short period of time just to melt the solder. But this is something that's a lot easier to do when you've got a microscope, because you can watch the state of the solder change from solid to liquid, and you can sort of see what's happening instantly. I would really recommend for anyone who's doing soldering work, okay, not everyone's going to have a microscope like this. They cost a lot of money, but at least go out and get yourself some of those, maybe those jeweler's goggles that you put on over and have little magnifiers out the front, so that you can really look at this stuff up close, and you will get better results when you can see what that solder is doing. So let's now have a look at the component that I took off, and we'll see what condition that is in and whether we need to do anything to that. Now, I really do like the idea of cleaning this up a little bit. And the way I would generally do that, the first thing I'm going to do is I'm going to try and hold this thing secure. So I've got one of these little clampy things like this. And I'm just going to put this, hold it sort of like this. There we go. Which is just going to allow me to have that kind of a little bit more still than if I was just it was just sitting on the bench top here. Mind you, I don't think it's going to work very well because it's lifted it up. But anyhow, then I'm going to get some flux onto this. I mean, a sensible thing to do would just be to get a new component, because we don't necessarily have the luxury of doing that on these really old computers. A lot of these components are getting really hard to find. Some of them impossible to find. Some of them you will, if you jump onto somewhere like AliExpress or eBay, you will find people selling some of these old components. They're old stock. So I've just got some solder and some flux here, and I'm just running my iron over these pins. And what I'm trying to do is I'm just trying to get new solder on there and push all the grit out of the way. You can see there's quite a bit of grit on this here, so I'm just trying to push that grit out of the way, and so I'm doing a gentle rub on these pins here. Sorry this is bouncing around so much. And then I just need to do the same on this other one. Oh, just mangling that pin there, that's no good. Do we need that pin? Do we really need that pin? I need my bigger tweezers. I'll stuff it. You know what? I'm just going to hold it down with my tweezers. Okay. Oh, it's so much easier. Why don't I just do this from the start? Okay. Just getting all these pins looking nice and shiny. Okay. Then I might grab a little bit of Wick, which is that's my thing. Wick's my thing. Would you ever ultrasonic components by themselves? Yes, absolutely. I have done that sort of many times before. I have this little mesh here for that very purpose. So this is just a little piece of metal mesh that I got no idea where I got that from, to be honest. I think it might have been out of a strainer or something like that. And what I do is I just sit that on the little cage, the little basket thing that goes into the ultrasonic cleaner, and I pop my components on that, and so that stops them from falling through. So yes, I have definitely ultrasonics just components on their own, depending on the state they're in. Okay, now let's just get some wick here and wick up. The reason why I'm wicking up this solder is because I want these pins to sit flat on the board. If there's little knobs of solder on the bottom of them, it won't necessarily sit flush. So just doing that, just get that. Okay, there we go. And once again, sorry it's bouncing all over the place. It's a little bit difficult. I'm just going to now get a toothbrush. Here's my toothbrush. And some isopropyl alcohol. And give it a good old scrub. God, look at all this fluff I keep picking up. Fluff everywhere. I don't even know where that came from. I mean, I know it was on the end of the tweezers, but I don't know how it got onto the end of the tweezers. So much for cleaning it. It was cleaner before I started this, wasn't it? Sorry, I need to find my big tweezers. This is driving me bananas. I have big tweezers and small tweezers, and the big tweezers give me the advantage that I can actually hold this component from the sides. And so I'm then going to just keep going at this. Oh my goodness. Okay, we're getting there. We're getting there. Oh, fluff. Okay, there we go. Right, I think we are clean enough now. Oh, look, these tweezers don't meet in the middle anymore. I hate it when that happens. Okay, I just bent a pin here. I'm going to bend it back into shape. Right. Okay, so here's our component that's been cleaned up. Not terribly well, but it'll be fine. And then we've got to put this back into place. Now, when it comes to getting the orientation for these, this particular component, as I said, which is a PLC, it's like plastic leaded chip carrier or something like that. And all of these have this little indentation in there. You can see that indentation there. That refers to pin 1. That's like pin 1, and then 2, 3, 4. I think I'm going the right way around. Going around in, what is that? That's counterclockwise. I'm pretty sure that's the way around it goes. 1, 2, 3, 4, 5, and then all the way around. So that there is the pin 1 indicator. And that there, which is a dot on the board, that is showing me where pin 1 needs to be. But then you've also got the fact that this has got a square edge, and a square edge, and then a square edge, and then a little beveled edge here. And you can see there's a beveled edge on the screen printing as well. So we've actually got 2 different ways of identifying the way around that this particular chip goes. All right, so now we need to get this. This has still got fluff all over it. Never mind. It's going to solder on okay. So now we need to solder this on. And what I do with these is I apply a nice liberal amount of flux to my newly cleaned pads. And then I drop this down in the correct position. And I just do this. I basically have to just, I'm looking to try and get it right in the top left-hand corner. And right in the bottom right-hand corner. Because once you start soldering this down, if you know you're off a bit, you're going to be off on a whole bunch of pins. So you need to try and get this as straight as possible. Now, the next thing I do is tack it onto the board. And by that, it's like the same as if you were doing tacking with welding. I just attach one single pin. And it doesn't really matter which one it is, but it's got to be one sort of in the corner. So I've got this here, and I'm going to tack this one here. Okay, so that is now attached by one pin, just there. Just one single pin attached in the corner. Then I am going to tack a pin on the other corner. So I'm going to spin them around. Ouch. And I'm going to shove a pair of tweezers up under my fingernail, because that's always fun. Okay, so that's my first tacked one is there. and then I'm going to tack another one down at this end. Doesn't matter which one, but I just want to tack that one there. Okay, so now I've got this reasonably secure by using two pins soldered at either ends of the component. So he's not really going anywhere now. He's in a pretty secure state. So the next thing to do is to pick one of the sides that I haven't tacked yet, and I haven't tacked this side here, and I haven't tacked this side here. And then on one of those sides, we then just do all of the pins. And I'm going to do that with a method referred to as drag soldering. It's something which is often criticized. People say you shouldn't drag solder. In my opinion, when you're doing these PLCC chips, it works really, really well. I've got the bevel of my iron, I've got the flat part facing downwards, and then I'm tucking it into the gap here. So I'm going to push this into this gap. I'm going to hold the top of this with some tweezers, and I'm just going to run this across like that. And you can just see these little kind of like buttresses forming as the solder attaches to the bottom of the pin and then onto the pad. I can use a little bit more solder here. One of the reasons why people, I think, are against drag soldering is that, first of all, if you haven't got a lot of good quality flux on there, you can end up creating bridges. You can end up joining, sort of two pins together with a little blob of solder that goes across. And the other is, of course, that you can sort of damage pins, damage pads, depending on the type of chip you're using. And I'll mention that and I'll show you an example of that in a minute. Okay, so we've got one side done. I'm going to now do the other side. Now, of course, I've got no pad here because I ripped him off aggressively. Just going to grab a little bit more solder onto the tip of my soldering iron here, and just going to keep running that across till I'm content that I've got good joins on all of these pins. Yeah, Jay said drag soldering rules. Look, at the end of the day, if you are when you've done a bit of soldering, drag soldering it's just one of the tools that you have. You don't necessarily drag solder everything, but there are times when you're working and drag soldering is just the way to go. Okay, we've got this again, shoving it in here, drag soldering it across, making sure I'm getting heat on the pads, heat on the pins, and then the solder just likes to join on. And then one more, one at the top here. Going to need a bit more solder. Yep. And there we go. Once again, now, as you can see, when I'm putting this, the soldering iron doesn't hang around in any one location for a very long time. And that's what I sort of mean by when I was saying that I use a very high temperature, but then I regulate that temperature by the amount of time that I spend with the soldering iron in a particular location. So, I just move the soldering iron around quite quickly. It melts very quickly, and then I can just sort of, run it across and then let go, and then it cools and solidifies. So this has now been put back in place. Now what I'm going to do is I'm going to grab my microscope, and I'm going to hold it in a way where I can look at this at an angle. So let's see if I can get this up high enough. Okay, that's all right. I mean, it's such a smeary picture. I do apologize. I've got to get that sorted out. But here we can see that we've got the solder going from the pad up to the pin and not joining between the two of them at all. So there's no bridges created here, but each of those pins have been soldered to the pad. And so that one is in place. So doesn't it need the pad back that you removed? No, it doesn't, because it's a not used one. So I'm just going to where are we? I mean, it's not going to fall off or anything. It's held on with enough components. There's not that one. Which one was it? Oh, there it is. So let's look at that from this angle. So that pad wasn't going anywhere. There were no traces coming off it. So that pin doesn't actually need to be attached to anything. So that is it there. It's held on with those forward, and that last one is just floating off into space. So, so no need to actually repair that one. That's why I ripped it off with such impunity. So, okay, so they're all connected up. I mean, they may not be the prettiest joints in the world, but as I say, it's a pretty grubby old component. But that would be enough to, sort of for it to work, assuming, of course, this computer did work, but it doesn't. Let's get rid of this old pad here, that reminder of my aggressive nature. Okay, so the next thing I'm going to do is I'm going to pretty much just do the same thing. We're going to do it with this component here. Again, we've got some pretty ugly traces going. Now, they've even done a trace repair here from there to there, because this was an absolute dog's breakfast, this trace here going through to that via. And I mean, look at this one. Look at that. What a shocker. Let me see if I can zoom in a bit. Yeah. Ooh. Fair bit of corrosion going on there. Nasty. Okay. Okay, Grudy, I can tell you what you missed. You missed soldering. Okay, so what I'm going to do now is I'm going to just whip this little fellow off. Cool whip. I'm going to whip this off, and I'm going to again clean up the pads, and then I'm going to put this on. But I'm going to, again, the process is largely the same as what I did with that component there. These are nice big thick pins, so drag soldering would work again. Let me tell you where drag soldering I would have to look at it a little bit differently. Something like this, or even let's go to, here's the 68030 CPU, and when you look at these pins you see how thin they are and how close together they are. If I was to drag solder along here, I would really run the risk of bending these pins. So I might still drag solder very, very gently, but I wouldn't necessarily recommend drag soldering for something with such fine pins there. But if we're talking about these sort of components that have nice big thick pins sticking out the side, on older components on an old computer like this, then yep, drag soldering is fine. All right, so this one here I think might be a little bit more interesting, because I suspect we might see some damage on the pads when we lift it off. But we're going to remove it. I'm just looking to see. Yeah, okay, so that there is an indicator of pin 1 right there. But I don't see any. Oh, there's the dot. Yep, there's the dot up there. I just wanted to make sure that when I remove this, I've got some indicator to show where it goes back on. Okay, so now I didn't do this last time, add some flux before removing it, but it's never a bad idea, particularly with these old ones. It will often help that solder melt and make it a little bit easier to remove the component. I better use a heat shield here because I'm right next to some plastic. I will probably wreck my trace repair while I'm doing this, but that's that. So once again, just applying heat with my hot air station around all the pins. I'm just going to keep it moving. Moving in a circular motion around, getting all these pins nice and hot. And I've got my tweezers here that I'm just going to be nudging it gently, and when I feel it start to move, then I can lift it up. A little tip for anyone who's using a hot air station, obviously one of the real risks whenever you're doing soldering is burning yourself, because there's so much bloody heat. And, you know, I burn myself all the time. It just happens. It's just part of it. Okay, he's getting ready to come off now. Where you can sometimes get a little bit tricked, lulled into false sense of security, you're watching out for the heat coming out of the hot air station, you're watching out for the heat on the soldering iron, and then you do something like I did now, and I promise you the ends of these tweezers will now be blazingly hot, and you've kind of forget, you put all of the soldering iron and the hot air station away, and you think, oh, that's all the hot stuff out of the way, and then you sort of touch your finger on the end of your hot tweezers. And so just be aware that you know, lots of things get hot when you're soldering, so you just have to be careful all the time. Um, I also want to just quickly mention the whole situation with solder itself and fumes and fume extractors and all that sort of stuff. I'm in the process at the moment. I'm going to be building myself my own little homemade fume extractor here. I have a little cheapy type one here with a little carbon filter in it. They don't do that much, but they're better than nothing. And I also have a fan here over my left shoulder, which is sort of blowing air across the desk to help sort of get rid of those fumes. Now I use leaded solder. I've always used leaded solder. I prefer using leaded solder. It melts at a lower temperature than unleaded solder. It's a lot easier to work with. And so I would generally recommend for anyone, in particular if you're sort of starting out, it's a lot easier to work with leaded solder than unleaded solder. So, you know, that would just be my recommendation. Go with leaded solder. What you do have to do is you have to be obviously cautious of the fact that we are dealing with lead, which is poisonous. The fumes that come up are not lead fumes. When you see the smoke coming up from the soldering iron, what's burning is the flux. Now, that's still bad for you. You don't want to be breathing that in, but it is not actually lead fumes. The lead actually is going to get transferred to your skin or to your eyes and mouth if you then touch your eyes and mouth and you've got lead on your hands. So you should be wearing gloves exactly like I'm not. You should, of course, wash your hands thoroughly after working with solder, and you shouldn't be touching your face if you've got got lead on your hands. So that's just that's just sort of a precautionary thing when you're working with solder. But I will always recommend leaded solder over lead-free solder. So okay, so now that we've just seen that I'm absolutely and totally flaunting safety stuff here by not using gloves, I do have gloves. And I probably should wear them today. I might decide to put them on. Maybe. Okay, so same as with the other ones, we've got these really ugly looking pads here. We need to make them look nicer, and we're going to be doing that with flux, with heat, and with new solder. So we're going to get some new solder here. We're going to get the soldering iron. We're going to do some gentle rubbing around here. And as you can see, when I do this, a lot of the, what do you call that? The mask is coming off these traces here, and that's because there's a lot of trace rot going on, a lot of heavy corrosion, and so that mask is just coming straight off. But we are getting rid of the black stuff here. These are starting to look a little bit better, even if they are out of focus. Yeah, let me tell you what chip. This is the egret chip. Egret. Okay, so that's the one with the no labels on it. It probably did have a label on it, but this board has been through the ultrasonic cleaner already, and sometimes the ultrasonic cleaner just takes the labeling off chips, and then you can't see what they are anymore. It's always handy to have another board around. Okay, just still going here. These are all starting to look nice. You can see that we have this kind of nice, you know, the word I always want to use is lozenge, you know, like a capsule. They have this nice little capsule shape about them once they've been cleaned up. And then we get our solder wick once again, and we soak up some of this solder. Soak. Oops, there goes my trace repair. There we go. Okay. And the other one. Okay. Still going. Just cleaning up here. Yep. Okay. Now, let's get some iso alcohol onto this, clean it up, and then we're going to inspect it a little bit closer and just see what these traces look like. Where are we? Remember, at any stage, if anyone wants to fire off any questions, I'm always happy to answer them. At the same time, if anyone wants to see anything specific, please do ask. I'm always happy to demonstrate anything if someone wants to see a particular process or something like that. If you're bored out of your skull and you'd rather I did something completely different, hey, suggest something. I don't mind. Okay. Now, we can see that apart from how smeary it looks here, we can see that this is, Dr. Google tells me, egret handles startup and PRAM stuff. Oh, okay. So, clearly this board will work after this. Well, I hope that this will actually make a difference. We will see. I mean, you know, this is a pretty ugly part of the board here. As you can see, I've already done a trace repair in this area, which I'll need to do again. Let me just get rid of some of this stuff here that's caked on. It's a bit of fluff caked on there. Right, so let's have a look here at some of the areas that I think are of concern. So I'm just going to twist this board around. The board's not very stable on the table, so I'm just going to move this a bit. There we go. Looking at it now vertically. So just working our way along these here. Which flux am I using? I am using Amtech NC. Let's get the old side angle here. Here we go. Amtech NC 599 V2TF. I buy it in a 30cc syringe like this. There are links in the description for where you can buy this. You can also buy it in 10cc if you want something that's going to last. You may not need as much as this. This is one that is specifically designed for working with leaded solder, and it is a no clean gel flux. And these are typically used for things like BGA rework, which is ball grid array chip rework. And these are, this is obviously, this one is reaching end of life. That's why it's so grubby. I have a, where is he? Here he is. I have a nice new clean one here, all ready to go for when this one runs out. And yeah, it's an incredibly important component. I have used other, sort of no clean gel fluxes, and they're all fairly good, but I do like this one. I find that this one hangs around, because some of them, they just burn away too quickly. Some of them leave lots of really ugly black stuff behind. Some of them stink, really stink. I mean, these don't smell that bad. I mean, I know we're not supposed to be sniffing this. I'm not actually talking about, sitting here and inhaling it, but they don't smell as bad as some of the other ones. So I do like this one. It's a good flux to use. But what I would say you don't want to be using is you don't want to be using an old-fashioned resin type flux like this. This is one that I bought from my local electronics store as a demonstration. That's what we often like to refer to as rotting meat flux. So this is the stuff here that I would generally say don't use that. It's fine if you're soldering some wires together or doing a little bit of household stuff, but this is not for electronics work. Some are foggy. That one's fine. JK, any good? What about those flux pens? Flux pens, yeah, they're okay. I have to say, look, this is a JK comment, and I do intend actually writing them a letter one day. JCar, for those who are not Australian, JCar is an outlet of electronic stores here in Australia. I actually have one within walking distance from my house, which is very handy because that's where I buy things like my solder wick, which I go through quite a lot of. And the JCar have this sort of flux. They have flux pens. they've got, I think, another type of flux, but I have never really found the flux that JCar sell that I like. I buy fluxes from other places, from places like RS Components or Metronics. If you're looking for Australian providers, you can get better fluxes like no clean gel fluxes. So, yes, a flux pen I think is better than, say, using something like this. But for this sort of work, for electronics, I really recommend going with a no clean gel flux. So, yeah. So Dana has said, some are foggy and we can't see what you're doing. Yeah, I know. I'm not quite sure why this microscope is showing a really foggy picture at the moment. I think I would have pulled it apart and cleaned it beforehand if I realised, but the process of pulling this apart and cleaning it is quite an involved one, so there's not really that much I can do about it at this time. Can you show how to tune a carb on a 446 pack? Well, no. Well, I can certainly explain how to get things like the mixture right and stuff like that, but yeah, I mean, in terms of a full carby tune, no, not necessarily. And actually, I've got a V8, not a 6-pack on my phone. So, yeah, what are you going to do? Okay. Oh, you mean the flux microscope is good. Good, I'm pleased to hear that. Yes. Oh, yes, you meant that this was blurry and you couldn't see. Yeah. Okay, that's all good. All right. So now I have gone off on a tangent here, so I'm going to just quickly jump back to this microscope, and we'll have a look at this. What I am going to be looking for here is to see whether there are any breaks in here. Now, of course, I'm holding this one here because this is going to be like a pantomime, and it's going to be like, there's a break in front of you right there, look at it. And if you're referring to this little black line down there, I would say that's probably a 50-50. When these traces are in place, at this point where the sort of trace meets the pad, there's often a little dip in there, and that dip can sometimes break there. It is a good place to check, but often that dip is there, and that's still good continuity. So I'm going to test that now with my little machine that goes bip. I'll put that nice and close to the microphone so you can hear the bip. Very important thing to have if you are going to be doing any sort of soldering is a digital multimeter. They're not particularly expensive to buy. This one is, because it's a bloody Fluke, and Fluke, they're making incredibly good quality stuff. They're ridiculously expensive. So Fluke, I think you guys are awesome. Give me free stuff. So this, but you can buy really, really good quality, cheap digital multimeters. If you buy one, the most important thing to do is get one that is auto ranging. Because if you're in a situation like when we were helping one of our fellow Macyakas use his digital multimeter the other day, and he was like, what setting do I put it on? And one of the problems with the ones where you have to set the range is if you're testing a battery, you've got to then sort of click it over to the correct setting for that voltage of battery. Whereas an auto ranging one, you just put it on volts, and then you just test, and it tells you how many volts there are. So make sure if you're going to buy one, get one that's auto ranging. But that's enough of that. All right, so let's go in and check and see what happens. So if I'm going to put one little tip there, one here. No, we're good. So even though that looks like it's a great big break in there, we do still actually have continuity. So let's keep working our way around. No, I don't see anything looking too bad there. Disappointing, isn't it? I mean, you look at something like that and you think, oh, that's got to be broken, but it wasn't. Let's just try this one here. Beep. 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 Okay, well, nothing here looks like it doesn't work. So there's look, I confess I'm a little bit disappointed. I was really hoping there'd be one that wasn't working there. But the other thing also have to keep in mind is the fact that when I go through that cleaning process and I, and I re-tin all of that copper, I put a layer of solder over the top, it can often end up repairing a broken trace somewhere. So now, what I need to do is I'm about to put this component back, and one of the big issues I have here is, oh geez, I bet you there's some busted traces under here. Look at that lot. Wow. 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 I'm just pretend I haven't seen that. Okay, so what I'm going to do is grab anything is possible with this one, Steve. I'll be honest. This computer, I really don't think I'm ever going to get it working. So I'm just going to grab some wick here, and I've got some solder that I've put on it, and I'm just doing gentle circular motion on these traces, and I'm deliberately scraping off the sort of the solder mask, that green coating, exposing the copper, and then coating it with solder or solder, depending on how you like to say it. Right, and the reason why I'm doing that is because I am basically applying some protection to it so that it doesn't corrode and rust in the future. If I just left exposed copper like I had there before, move over the way. If I just left exposed copper, it would corrode and rot through and look awful. I mean, it's a precaution I really probably don't need to take because I think this computer is shot. But I am still doing it anyway because, you know, proper job and everything. Right. Time for the new component to go on. Wonder if you could hack the flute to go wild eep when continuity is established. How good would that be? I would love a wild eep multimeter, but I don't like the chances. Certainly beyond my electronics capability. Right, so now let's get this component stuck to the table. This is the one that I lifted off. Let's just have a look at it and see how it looks underneath. Got a bit of goop. It doesn't look too bad. I'm just going to hit that with some focus. And hit that with a little bit of wick, I reckon. Okay, back. Once again, I just want the surface of these to be flush so that when I put it down on the board, oh, look at all the scunge under there. Scunge. I might actually, one of the things that I do sometimes do, if I'm trying to clean up these pins, what I'll do is I'll put it like this. I do apologize this whole chip doesn't fit in the full view here. I get some flux like this, and then I get some solder and I put some onto the iron like that, nice big glob. I grab some tweezers to hold this still, and I just rub backwards and forwards here with flux, new solder, and heat. All smoking away. I'm just getting rid of as much that old crusty corrosion on these pins. Ooh, burning my nice table too. And then I'm going to get my wick, wickety whack. And look at that. Look at those lovely shiny pins now. Okay, I have to log off, but I'll catch the rest of the stream later. Thanks for all the useful info. You're welcome. Thank you for watching. I do appreciate you hanging around, and I do realise that this can be extremely boring, and that's one of the reasons why I am happy to take requests and answer questions. Do the same on this side that I did before. Focus. Okay. The magic of flux and new solder and a little bit of rubbing. We'll get this thing looking good. Yes, sir. All right. Yes, actually, how many viewers do I have? I haven't even looked. 14 concurrent viewers. Hello, 14 of you. Thank you for watching. I do appreciate you hanging on and sticking with me while I fiddle around with the soldering iron and components and stuff. Okay, so this is now a lot cleaner. I can get a toothbrush here and give it a bit of a scrub-a-dub-dub. And once again, these pins will now be a lot happier to take solder on because I've cleaned them up, got rid of a lot of that nasty corrosion, all of the build-up and scunge on the outside. So they'll be in a much better position for sticking onto the board here. All right, so there is our out of focus. There we go. That's good. That's good. All right. So we know this needs to go on with the dot. Whoops. This way. There's a dot up there, and there's a dot down there. So the first thing we're going to do is smother it in flux. Oh God, look at this. What is that? Like insect hair? Insect wing or something? It's one of the downsides to having your workshop in a shed. Okay. Then we'll get our component. I'll get my big tweezers. Try and clean them a bit. What is a classic Mac accessory that you always dread repairing? Mac accessory. Earwax, it's here. Was that earwax, was it? Oh, cool. The Mac accessory that I always dread repairing. Mac accessory. I don't know. I haven't repaired many Mac accessories. I mainly just repair the Macs themselves. What about you, Steve? What's a Mac accessory you dread repairing? Okay, so I'm doing this in the same way that I did with that PLCC chip. I'm basically just going to try and position this as best as I can. So I'm lining it up at one end and the other. And then I'm going to, once again, do my little tack at one end. So this board's kind of hanging off the edge of the desk here, which is why the focus keeps going out. So I'm going to get a little bit of solder onto the end of my soldering iron tip. And I'm going to hold this in position. And I'm going to do one pin. Just like that. Just the one. I'm going to flip them over. Anything with caps that could pop, yes. We love watching it when the caps pop. It's so entertaining. Okay, so there's that. And then I'll tack that one. Okay, so we've got one tacked at that end, got one tacked at that end, and then this component is held in position for us to do our drag soldering once again. So, drag, 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 drag. Drag, what a drag. Okay, I'm running out of solder here. I need a little bit more. There we go. Okay. Beautiful. Beautiful, just beautiful. I mean, melting plastic. I'm going to have to spin this around. Don't want to melt plastic. Okay. There we go. There we go. So, once again, drag soldered. Haven't ended up with any bridges. It would be a different story if I didn't have any flux. And I'm just going to demonstrate that right now. I'm going to get some isopropyl alcohol. I'm going to clean away some of this flux. And I'm going to show you what happens when you try and drag solder without a good flux. That trace looks nasty. The one on U9 or parallel to it. Let's go and have a look. Go and have a look. Gonna blow some of that isopropyl alcohol away. Okay. Right. U9, 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 U9. I mean, it all looks nasty, but yep. Hang on. I need to revert back to the nude eye. Okay, where are we? U9, 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 U6, U14, U15. Oh no, it must be close. U11? Can't find it. The big chip you were just working on, that's U9, is it? Oh, okay. I didn't even see that. Oh, it is too. The trace looks nasty, the one on U9 or parallel to it. Okay, let's have a look. Let's have a look. Parallel, you talking about this trace running along here? Yes, it does look very nasty. And I actually did do a trace repair on this which fell apart. So I'm going to re-establish that trace repair. So this is all bendy now. It was beautiful and straight before. Can I survive? Can I live with that? Can I live with a bendy trace repair instead of a nice flush straight one? There we go. Oh, I only just got that in camera. Okay, so Anthony Aegis, thank you for joining. Dana Siberia sent me here. Sent you here. Okay, well, I hate to tell you this, but we've been going for a while, so someone will have to fill you in on the plot. Otherwise, you won't be able to follow it. I'm just joking, of course. Right. Okay, so that's on. And as I say, what I just wanted to do, there's still a bit of flux in there, so it may not necessarily, this demonstration may not work the way I wanted. But what I wanted to show is if I am going to be doing some drag soldering here, now there's still flux in there. Now, you can see it happening to some extent, but if you're not using flux and you're doing a bit of drag soldering, you are more likely to end up with, you can see it actually just happening here, where that's got a little point to it. It's not a little smooth. It's not a smooth join. You're more likely to end up with a bridge between the components. I'm going to add some more solder in here. Let's see if I can force a bridge. There we go. Got a nice big bridge there. Now, there's too much solder on there. I can obviously grab some wick and I can remove that. But what I want to show is that if I then douse this liberally in flux, when I then move that around, that bridge goes. And that's because that solder becomes much more fluid with the flux, and so it then is more likely to just hold together in a little glob rather than being stretched out and spread across and ending up creating an accidental bridge. So that's sort of demonstrating how important flux is when you're doing this sort of stuff. So I have removed a couple of components. I have cleaned the pads underneath them and put them back on, and that was pretty much what I wanted to demonstrate. I can, of course, show some other stuff if people want to, or if someone wants to ask any questions about equipment or about tools or anything like that. Please do so. Otherwise, I'll probably consider sort of just wrapping things up. I've been going for a little while now. And it was never really meant to be a super long stream. It was just the plan was to do something a little bit different this time around, rather than just doing yet another recap, which I will be doing anyway. But can you solder a component with the hot air gun? Absolutely. So that's another way of basically doing it. And depending on the sort of component, you might want to actually do that. And what I'll do is I'm going to solder a component using the hot air station. And let me just see if I can find one that kind of needs to be done. Well, look at that bridge, or that little piece of solder in there. Yeah. God, I've always got grit. It's got grit. Okay, so here's one that could potentially be redone because he's looking pretty ugly. That's there is just no shortage of ugly ICs on this board. It basically just happened. So first thing I'm going to do is take him off. I'm going to go through the same process. I'll do this as quickly as I can because I've already shown this a couple of times. That can be a little bit on the dull side. But let's just apply some heat here. I'm getting really game here. I'm doing this without putting a heat shield next to some plastic. So I'm watching that plastic like a hawk to see whether I'm melting it. So far so good. Okay, going. Coming. Here she goes. There we go. Okay, that's the component off there. So we're just going to go through the same process we went through before. We're going to be adding some flux, and look at that little piece of metal. I might remove that piece of metal. What do you reckon? Come on, flux. There we go. Right. And then we're going to get some solder here. And we're going to clean up these pads, as we have done before, with flux, heat, and new solder. And some gentle, very gentle rubbing here of these pads. Being gentle because, as I demonstrated before, with a little bit of heat and a little bit too much pressure, you can just tear these pads right off, and that is not what we want to do. So, just cleaning these up until they don't look horrendous anymore. Right, now we'll get some wick. Wickety whack. Some solder wick, some solder John Wick, some Bubby Yeager wick. There we go, there's a little bit of an esoteric reference. Okay, and then just soaking that up, and then at the same time also doing a gentle rubbing motion. I'm coating all of this old crusty copper or rotted copper with a bit of solder, tinning it, making sure it's protected so that it won't oxidize. Okay, so that part is pretty much the same as what we were doing before. Now I'm going to clean it with Q-tip and some isopropyl alcohol. Cleaning. And we're going to have to do the same with the component. I'm just doing this all in fast forward at the moment because I have done this before, and so I don't want to just sort of be even more boring. Okay, here we are. Here's the component. This one here is pretty crusty as well, so I'm going to do the same trick that I did last time. I'm going to put a whole stack of flux along here. Now, I have my workbench in here is quite deliberate. I bought a table, nice laminated table, and then I bought some plywood, and I cut the plywood to the same size as the bench and stuck it on top. And so I don't care about burning this at all. When this gets wrecked, completely and totally burned to beyond being able to be used, I'm going to lift off the plywood from the top and put a new one down. So I'm just sort of mentioning that because, as you can see, when I just hold this component to the table and I burn bejesus out of the table. That's just because I don't really care about that. It was designed to be burned. Alex, hey Bruce, can you show me how you might repair a broken leg on an IC like the one you're reworking now? Got a few tiny sick. Yes, I can. In fact, how about I do that? How about I bust one of the legs off this? I do actually have one. Actually, here's one. Here's one I prepared earlier, I think. Is that it? Nope. Is that it? Nope. Is it even in here? Maybe. No, it might not be here. It might be up in the main house. So, all right. So let me just quickly clean this up, and then we can kill two birds with one stone. I will repair a leg. So just using some solder, some flux, some heat to just clean these pins up. Okay, spin them around and do the same here. Need more solder. There we go. Now the process that I'm going to show with repairing the leg works with plastic IC carriers, like this one. It doesn't work so well with the ones that are made out of that, I don't know, kind of like ferrite sort of material. I'm not sure exactly what the material is, but some of the really old kind of ROM chips on these computers were made out of this. It's this really hard sort of metallic substance, and you can't cut it. I mean, if you try and cut it, you'll just blunten anything you try and cut it with. So just cleaning up. Oh, look at me, I've bent some pins. Getting carried away here. Yeah, look how badly I bent these pins. I was just mistreating them terribly. So I'm going to try and bend some of these back. At the end of the day, as long as I can get them soldered onto the board, I'm happy. There we go. Bendy, bendy, bendy. Bendy. Same one here. Bendy, bendy, bendy. Now, which one? Which one am I going to wreck? To make it easier for myself, I might just bend one off the end. So, What are you doing, Bruce? Why are you doing this? What on earth? Oh, ta-da! Vandalism. Right, let's just clean this up a bit. I'm just going to hold him with some tweezers while I give it a bit of a scrub. Try and keep it in the microscope. Okay, so I'm going to demonstrate two things here. The first thing I'm going to demonstrate is I'm going to demonstrate putting this component on just using the hot air station. And then I'm going to demonstrate re-establishing that busted pin. So let's start with the hot air part. Now, what I did before, if I can just find out where this came from, here. What I did before when I was putting those other components on is I had these pads perfectly clean, put the component on, held it in place, tacked a couple of pins, and then soldered the rest on. It's the way I like to do these particular components. On newer computers with the smaller components, you wouldn't necessarily do it that way. But this is the way I like to do it. But what you can also do, let me just get some flux on here, is you can solder these on using hot air. And the way you would do that is the first thing you do is you get some solder on all these pads. So got some flux there, get some solder, and do a little bit of this. Yeah, it's a little bit difficult with this because there's all these traces are exposed, so they're sucking up all the solder. Okay, so once again, this is what I referred to before as these all looking like little capsules, little lozenges, like that. So we've basically now got solder, a little bit of solder on all of these pads. Now we are going to apply some more flux. Flux is a big deal. And then we're going to try and find the component. I'm so good at losing components. Here we go. It's under the toothbrush. So we need to find out where it goes that way. And if you're wondering how I know it goes that way, there are two ways I can tell. First of all, we've got this little silk-screened curve here, which lines up with this little curve here. And then we've also got a dot here to show pin 1. And we've got a dot here to show pin 1. So, okay, so what we're going to do now is we're going to place this component pretty much where we want it to sit. And we're going to use a hot air station. Now, what I usually do with this is I drop the hot air station down a little bit in the amount of air it blows out and turn up the temperature a little bit. I have it set most of the time on 120 air pressure. I don't know what that 120 refers to. I'm not sure what the units are. But on this particular hot air station, which is a Quick 861DW, 120 is the most air it can blow out. It's as fast as it can go. And then I have it set on 400 degrees Celsius. Oh, that's nice and warm. I have another setting that I have set up on this one for 425 degrees Celsius, but only 55. That's the amount of air it's blowing out. So it's blowing a lot less air. Because when you're putting these components on, if you're blowing out too much air, you can end up just literally blowing the component off the board. So I am going to now apply some heat to this. And I'm going to melt all of these little lozenges that I was talking about before. And there we go. Oh, having trouble getting it exactly straight. There we go. I'm just going to let that cool a little bit. And then I'm going to apply some pressure from the top and heat it again, so that I make sure that I've got this nice and flush on the board. I do apologize that you can't see all of this. That is just one of the downsides with this microscope. This microscope doesn't have enough field of view to show you everything. But there we basically had that soldered on without doing any of that drag soldering. What we just did was we put the solder on the pads, then just heat the whole thing and then just melt it on. And it works just as well. I mean, they're all of those pins are now soldered on. So that's fine. Now, if you're working with a smaller component, let's just say, I probably need to do it on the other side. Let's say if we were dealing with a little tiny, something like a capacitor or something like that. Let's say we were going to replace him. So I'm going to take him off. I'll take this guy here. And that red stuff that you can see there, that is component adhesive. Excuse me, and that's because of the way these boards are manufactured. They stick all of the components in place first, and then they run the board through a solder bath, and then the solder just sticks to the metal parts. So I'm just going to clean up these pads here, and I want to show you if we're just dealing with a little component like that, a little bit different to how we would solder on that component that I just did. Okay, again, cleaning the pads. Always start with clean pads. You'll just always end up with a better result if you start with clean pads. So let's just put some flux on there and get some nice big glob of solder on here. Now, when I get this component, which let's hope I haven't lost, here it is. When I get this component, once again, making sure I've got plenty of flux on there. Wrong view. Sorry, I keep bumping the mouse, sorry. I'm going to get this component, I'm going to pop it on there. And what I need to do is I need to hold this component so it doesn't blow away. Like that. I need to apply heat to make that solder melt. And then place that on. Right. Okay, now that's on. But here's the really cool thing about when you're using hot air for little components like this. If I apply a little bit of flux on there, and then I apply some heat, you will actually see, usually, this component's a bit big, you'll usually see the component actually just, there it is. Did you see it there? It just settled into place. It's actually it pulled itself into place there, and it didn't actually pull itself. What did it was the surface tension of the solder. The solder just created a little blob, and that when it created that shape, it just pulled the component into place. And so that's a way, you know, you get these components sitting lovely and flush without you having to desperately try and get them in position. You solder them on, you know, sort of you get it so that the solder is holding the component in position, and then you know, apply the hot air, and then that surface tension just pulls that component into line. And so that, you know, as long as you don't have too much air to blow the component away, that sort of just that gets that component where you want it to be. So that's how you would do it if you're dealing with a small component like that. Just position it, you know, once it gets held into place. And again, you can see where the microscope comes in handy when you're doing this sort of stuff, because I can actually see the moment that solder becomes molten versus when it is. So I just saw it then, bang, just went molten. Take it away, and I missed it going solid. But anyhow, the point is that the microscope really does help when you're doing that very small component rework stuff. So I have still got something that I need to do here, which I said I was going to do, and I am going to fix up my busted pin that I have here. As we can see, we've got no pin there. Now, what we need to do is we need to expose enough pin for us to solder something to it. And at the moment, I don't really have enough. I could solder something onto that most probably, but it would sort of very likely break away quite easily. There's not really enough there. Now, what's kind of good is that a lot of these plastic chip carriers, this pin goes quite a long way into that case. And so it's just a matter of sort of exposing some more stuff to solder onto. Now, there are a couple of ways you can do it. You can use a Dremel with a little cutting tool on it. I've done it sometimes just with a scalpel blade. I'm going to grab a scalpel blade now and just see how I go with this. I mean, I don't want it to take too long. So if I start gnawing into this and it looks like I'm going to be here for a week trying to get the thing exposed, I might just then go and grab the Dremel. I've only got quite large cutting tools for my Dremel, so that concerns me. But basically what we're wanting to do is we're wanting to scrape away this plastic, because this is just plastic. It's just a coating on the outside. I know the focus ain't too crash hot, but it's because I keep moving. I'm just going to keep scraping, and I'm just scraping away the plastic of this chip carrier or package. Keep scraping, and I mean, look, you can keep going quite a long way into this, and there'll still be pin there, but you just got to decide how far you want to go in. As you can see, I've exposed quite a bit more of that pin than was there before, but let's keep going. We're not quite at the watching paint dry stage yet, but we're getting close. Hey, what did you do today? Oh, I watched this guy scrape some plastic. It was awesome. It's some of the best plastic scraping I've ever seen. Yeah. Okay. All right. Do we consider that enough to solder something onto? Let's give it a whirl, shall we? Okay, so now we need some wire to use for this joint. And what I would generally do with this is Okay, let's just clean that up. So I'm using this wire. Now this is enameled wire. You don't need to use enameled wire. It's just because it's the wire that I have. And you know, when you apply some heat to it, you actually melt the enamel off. I'm going to just cut this a bit. Okay. So, right. Now, what I'm going to want to do with this is I want to get a nice solid, whoopsie, I want to get a nice solid kind of sort of join. I want this to be on the board nice and solidly first. So I'm going to bend this a bit, and I'm going to just solder this onto that pad, and that's going to give me my initial strength and connection there. So get some solder onto my soldering iron, and get my wire, and just going to apply, I might just apply heat over here for it to start off with, just to melt that coating. There we go. Well, okay. Right, that ain't too crash hot, but it's there. I really should be doing this with tweezers. I'm doing it with my great big fat hands. There we go. That'll do for now. What I'm going to do is I will shuffle it around a little bit, but what I'm going to do is going to cut off the excess there. I might even trim a little bit off here as well, and then I will get it into a better position using some tweezers. So just cut that off there. Goodbye. Fare thee well. And then, okay. There we go. Okay, so that we now have soldered onto the pad there, and then we need to get this soldered onto that little nub. And so I'm just going to, this is probably a little bit too long. I would ideally like this to be bent around. We have to be really careful here because I don't want to tear this pad off. So I need to, I mean, this wire might even be a little bit thick. I'd like to, oh God, there's so much gunk on the tweezers at the moment. It's crazy. What's going on? Okay. Right. So we're just going to bend this, bend this and bend it good. A bit easier to see there now. Okay. This wire really is too long. There we go. Okay. Now, this is going to be really difficult because I want to solder this on without actually damaging the, without actually breaking the connection this at the other end. And it's because it's going to be very easy for me to heat this all the way through till it actually melts at the other end. Okay, there we go. That coating is coming off, and I've now got solder on there. So, just going to push that down. And that has actually soldered on there. I'm not sure how strong it would be, but it has actually done it. There we go. It's a little bit better. All right. So, let me just, yep, that's connected. You can zoom in a little bit here. And that has soldered onto that little nub. I can just give it a push, and you can see that it is held on at this side. So that has basically worked. It is not by any stretch my prettiest work. That is, if anything, probably one of my worst. but you know, I mean, oh well. It has worked, but it's just not very good. The wire is possibly is slightly too thick a wire, but the good thing about that thicker wire is that it has some rigidity, so it holds up. But I didn't cut off enough of it when I did it, so I've got this kind of huge curl going on here. Let me see if I can just move this microscope out so that we can look at this from a different angle, because it might make a little bit more sense what I've done here if we look at it side on. There we go. Can you see that? It looks like a little seahorse. You can see he's sort of soldered onto the pad at the bottom, then he's coming around and curling and sitting onto that little nub on there. Now, I've actually done this. You do get better at it as you practice. I did this on a chip, and I had to do about probably 8 of them along one side of a large IC, a big square one, and it worked. I mean, it sort of, after doing it, I was thinking, there's no way this thing's going to work, but it did. It did work. And obviously, when you finish something like this, you need to coat it. You need to protect it, because otherwise, you know, if this gets shaken or twisted or something like that, that could come apart. And that's where we use something like UV solder mask or a conformal coating that we put on it afterwards to clean it up. This, of course, would need to go in an ultrasonic cleaner before I did that. If I tried to stick any sort of coating on this now, I'm likely to just, it wouldn't stick, because there's all that flux in place there. But once this was cleaned with an ultrasonic cleaner, I would then coat that liberally in a, as I say, UV solder mask or a conformal coating. Conformal coating is basically a coating that conforms to the surface. So this is conformal coating here. It is it's like this clear, gooey, sort of viscous stuff. And then you just paint it on, it just sort of settles onto the surface, and then it takes about 24 hours to dry, something like that. Whereas the UV solder mask is something that dries a lot quicker, because you can dry it with UV light. So you can either dry it out in sunlight, or you can dry it with the UV globe. And that's the added advantage of that, is you can get something ready to go a lot quicker. So, for instance, if I'm doing a recap and I need to do some cleaning up, and maybe cover a few exposed traces or something like that, I would use a UV solder mask, because then I can just sit it under a globe for 15-20 minutes, something like that, and then I'm ready to go again. So anyhow, look, I think I've probably covered all that I really wanted to cover in this video, so I'll probably wrap things up now, unless people have any other questions or requests for sort of demonstrating something. I'm more than happy to oblige, but I think that's probably it. Where am I sitting at the moment? I'm sitting at 15 viewers, so thank you to those 15 people who have stuck with me for all this time. And I've got a beard here. Please, if you haven't subscribed, please subscribe. If you haven't pressed the like button, please press the like button. And you know what? If you hated it, feel free to press the dislike as well. Thank you, Gritty. I appreciate that. I felt like it sort of dragged a little bit there for a while, but I hope that there was enough in it to have been of value to someone out there that might have been happy to see a couple of those little processes. Thanks for the clarification. Okay, yep, no worries. So, and look, if you have any further, if you sort of after watching this think to yourself, you know what, I really would have liked to have seen this or that or the other, drop it in the comments section, because I do intend to do a couple more of these in the future. I want to sort of demonstrate some more through hole stuff. I'd like to ideally demonstrate some stuff with slightly newer technology, sort of things like these sorts of more modern boards, and showing how we sort of remove or replace components on ones like these as well, because these you really need to have a microscope. You really can't do those without a microscope, because the components are so darn small. Thanks again, everyone, for watching. I really appreciate it. Thanks for spending the time. I hope everyone is staying safe out there in these strange COVID times. thank you again, and I will catch you on the next stream. Goodbye.